Hello guys, this is Prime Concept. In this video, I want to consider another aspect of the quadratic equation, which we know as alpha beta roots of quadratic equation. In our previous videos, we have introduced quadratic equation, explained in details the concept of quadratic and how to solve quadratic equations. We have looked at the different types of roots quadratic equation can have. In this video, I want to consider alpha and beta roots of quadratic equation, a very important aspect. So I'll be taking you through a lot of basic concepts here that can help us build complex concepts in this. Now, very quickly, we recall that the general form of a quadratic equation is ax squared plus bx plus c equals 0. This is the general or standard form of quadratic equations. Now, we want to make an assumption, but before that assumption, we're going to divide through by the coefficient of x squared, which is a, so that we can get a new quadratic equation. So I'm going to quickly do that. Divide through by a. If I do that, I would have ax squared divided by a plus bx divided by a plus c divided by a equals 0 divided by a, so that this can fizzle this, and then I'll be left with x squared plus b by a x plus c by a then equals 0, because 0 divided by a is still 0. So let's call this equation 1. Now, since this is our general equation, we want to assume that the roots, remember quadratic equations would always have two roots, two values of x. That is to say, if you have any quadratic equation, your x can either be 2, then your second value of x can be 3. So you can have any combination of the two values of x. Now, since x can be any number, we want to call those numbers to be what? Alpha and beta. Let one of the values of x be alpha, and let the other value of x be what? Beta. We can use any symbol. I'm just using alpha and beta because this is the common symbols used in quadratic equation. So I would say let alpha and beta be the roots of equation 1. So they are the roots of this equation. Now, one of the things we want to know is that I can form a quadratic equation by knowing the roots. If I know the roots of a quadratic equation and I want to form that quadratic equation, one thing I would know is that x has one of the values to be alpha, or x has the other value to be what? Beta, since these are the two answers we have. Now, if I push this to this side, I would have that x minus alpha should be set as 0, or I would have that x minus beta should be set as 0. In order for me to form the quadratic equation, I would multiply these two solutions. So I would have x minus alpha multiplying x minus beta, set it to 0. If I carry out this expansion, let's see what we have. X times x would give me x squared. X times this would give me minus beta x. Now I'm done with this, so I'll go for this. Minus alpha times this would give me minus alpha x. Then minus alpha times minus beta would give me plus alpha beta. Now set this to what? 0. Very quickly, I want to rearrange this. So I'll have x squared. First, I'll bring out the minus because it is common. So I'll say minus. Then secondly, I'll bring out x. X is also common. I want to place x on this side so that it will look like our standard quadratic. Because usually in quadratic, we have x on the right. So I would have placed it here, which is still correct. But I just want to place it here for the sake of standard. Now, what do I have inside this bracket? You notice that I can have alpha then plus beta. I can still say beta plus alpha is still the same thing, but I just want to, for the sake of standard, put alpha first. then plus beta. Now, so that when you expand, minus times this will give you minus alpha x. Minus times beta is minus beta times x is minus beta x. It's still the same thing. So then plus this constant part, alpha beta equals what? 0. Now, if I call this equation 2, let's say this is our equation 2, right? I can compare equation 1 and equation 2 because both of them are standard quadratic equations, right? And remember, we have established that alpha and beta are the roots of this particular equation. So it means that by comparing equation 1 and 2, we have, so if I compare both of them, I would have, watch, the coefficient of x squared in this case is 1. The coefficient of x squared in this case is 1, so it is sufficient to compare them. Now the coefficient of x here is what? B over a, while the coefficient of x here is what? Minus alpha plus b over a. So let's do that. So from here, I would say minus into alpha plus b over a, which is the coefficient of x here, should be equated to the coefficient of x here, which is what? B over a. So that if I push this negative sign to this place, I'll just multiply the two sides by minus 1. So if I do that, I can then say that alpha plus beta is equal to minus b over what? A. So this is equation 3, one of the most important equations in what we want to analyze. So what I've written, remember, alpha is one of the roots, beta is the second root. So it means that this is an addition, this is a sum. So for short, I can just say sum, S-O-R, sum of roots of quadratic equation would always be minus b over what? A. So we call this alpha plus beta is known as sum of roots of a quadratic equation. So if I ask you, what is the formula for the sum of roots of a quadratic equation? What will you tell me? You'd simply tell me that it is minus b over what? A. We're going to finish up, then take an example that would internalize this concept. Now also, we want to still compare the quadratic, comparing this side, the constant side, the constant side. You would see that the constant here is alpha beta. Constant is the part that does not carry x. So you notice there's no x here, so this is a constant. So alpha beta should be equal to the constant here, the part without x, which is this, should be equal to c over a. So I'll call this equation 4. So please, never you forget equation 3 and equation 4. Now in equation 4, you will notice that the two roots are multiplying each other. So this is called product of roots, P-O-R, product of roots. So if I ask you, what is the formula for product of roots of a quadratic equation? What will you quickly tell me? You'd say it is C over what? A. So never you forget, sum of roots is minus B over A. Product of roots is what? C over A. So what it means is that anytime I want to form a quadratic equation, I would simply use this relationship. X squared minus sum of roots x plus product of roots equal to what? 0. So this is key to forming any quadratic equation. So quadratic equation would always be x squared minus sum of the roots times x plus product of the root. I'll give you a quick example for this before we look at further problems. So very quickly, we have example, the two roots of a quadratic equation are 2 and minus 3. Okay, let's say 2 and 3 for simplicity. 2 and 3, comma, determine the equation. Determine the equation. Very simple. Very simple. Now let's see how to solve this. At this point, if you are watching this video to this point and you are yet to subscribe, please, I will plead with you to just hit the subscribe button It's your way of showing support to this channel so that we can do more videos for you. Hit the like button, comment, and then share the video with your friends at the end. Thanks for always supporting prime concepts. Now quickly, the question says the two roots of a quadratic equation are 2 and 3. That is to say alpha is 2, beta is 3, or you can still say alpha is 3, beta is 2, any one, but know that the two roots are 2 and what? 3. Determine the equation. So using this powerful formula, I will just first of all find the sum of roots. Sum of root means adding the two roots. So it's going to be what? 2 plus 3, that is sum of root. They give us the roots directly. So we don't need to use the formulas, these formulas, right? Now they gave us the roots. So I have 2 plus 3, which is what? 5. Then product of root means multiply. Product means multiply. So product means 2 times 3, which is what? 6. So if I take these values back to this equation, I would have the equation to be x squared minus, then sum of root I got as what? 5. So I would say 5x, right? Then plus product of root I got as 6 plus 6 equals what? 0. And I've gotten my quadratic equation. You can see how simple and how fast it is. Now let's look at an example that would utilize this formula C over A and minus B over A. Let's look at the formula, an example very quickly. I will drop that. Alright, let's quickly solve this problem and draw the video to an end so that in subsequent videos we're going to dig deep into this concept. Now the question says, if alpha and beta are the roots of the equation, so let me write out the equation. 4x squared minus 16x plus 7 equals 0. If alpha and beta are the roots of the equation, this, find alpha plus beta, find the sum of roots. We can solve this in 2 ways or more, but let's go by the formula we just derived and I'll still show you something else. Now, first, from this quadratic equation, what is our A going to be? Our A is going to be what? 4, which is the coefficient of x squared. Then our B is going to be what? Minus 16. And then our C is going to be what? 7. So these are the values we know. Then we already know that alpha plus beta has a formula which we just derived, which is minus B over what? A. So it means that my alpha plus beta is minus, what is my B? My B is minus, don't forget, I will use brackets, minus 16. Then divided by my A, and my A is what? Is 4. So that my alpha plus beta, minus times minus is plus, so I have plus 16 divided by 4. So if I divide this, I will have 4. So alpha plus beta is what? 4. Now the second part of the question says, find alpha beta. From what we derived again, alpha beta is actually going to be C over A. So what is our C in this case? Our C is what? 7. And then our A is what? 4. So it means that our alpha beta is what? 7 over 4. Now I want to point out to you that the concept of alpha plus beta and alpha beta is very important. In my next video, we'll be looking deep into other formulas. They might tell you to find alpha squared plus beta squared. Any other thing they want us to find is going to be drawn from this. So when we get to the next video, I will explain. Whatever they want us to find different from alpha plus beta or alpha beta, the first thing we would need to always do is to find alpha plus beta, find alpha beta before any other relationship. So this is paramount for every problem, trust me. Now let's show you the second method of solving this and then we'll end this video. Now another way I can solve it is to divide all through this equation by the coefficient of x squared, which is 4. So if I divide through, I would have 4x squared divided by 4 minus 16x divided by 4 plus 7 divided by 4 equals 0 divided by 4. So if I do this, 4 can go. I'll be left with x squared minus 16 by 4 is what? 4x, right? then plus 7 divided by 4 equals 0. So you would quickly see that the sum alpha plus beta is going to be the negative of what you have here. So negative of negative 4. So it's going to be the negative of whatever you have here. So minus of minus 4 is going to give us what? 4. So you see I've gotten it. Then the other way, your alpha beta, your product is going to be what you have here, which is 7 divided by what? 4. So this is another way we can solve it and arrive at the same answer. But I would prefer this because it will be helping us analyze so many other concepts. So if you have followed this, I believe the concept is really very clear to you. Do well to subscribe so that when I post the next video under this, you'll be the first to be notified. Thanks for always supporting Prime Concepts. I'll see you in my next video. Thank you.